If there is one thing that drives the search for new planets, it is the prospect of finding new Earths. Terrestrial planets very similar to ours, which may even be able to harbor life. The so-called exo-Earths. For many people, with this research, we are taking the first step towards a potential colonial future. This idea is like an irresistible candy for many media outlets, which, at the slightest update of the exoplanet database, come up with headlines such as Earth's twin found. New habitable exoplanet cataloged. The nearest habitable exoplanet to Earth is real. Real. What a joke. The fact is that finding exoplanets identical to ours is an incredibly complicated task. I would even say it's impossible. Today, you cannot state that a planet is habitable until you put potentially in front of it. Why do some media say otherwise? I think it's due to a misinterpretation of this number, the ESI, or Earth Similarity Index. This number combines a collection of properties of the exoplanet to be evaluated: its mass, radius, the amount of light reaching it, its temperature. If the number is very close to 1, we have a supposed twin of the Earth. In terms of this scale, today some classifications put 20 candidates on the table. The best fit is T Garden B, which orbits a red dwarf only 12 light-years away from us. And we cannot fail to mention it, the TRAPPIST system has not only 1, but 4 candidates in a row. The dream of all futuristic fiction. Now, does it mean that we already have 20 potential colonies? No, not at all. The ESI helps us to know if the planet can support liquid water or if it receives enough light to develop plant life, but this isn't the whole story. For instance, will its atmosphere be breathable? Does it even have an atmosphere that has not been stripped away by the violent activity of its star? Some of our candidates orbit red dwarfs, small stars with particularly erratic and dangerous activity. There is no guarantee that a high-index paradise won't end up being a wasteland.
We will need to know how the star behaves, what kind of solar flares and explosions this star has that may have affected the evolution of its atmosphere and so on. That is, the process will be a little slower than we would expect.
And this is because, as we discussed in a previous video, today we can only see the atmosphere of the largest exoplanets. In general, exo-Earths are beyond our reach, at least until the next generation of telescopes comes online. And yet, even if we see those atmospheres, it will still be hard to detect habitable worlds. There are good grounds. Water has already been detected on many exoplanets. Even clouds are almost confirmed to exist, as well as indications of a lot of gases that we link to living beings. However, detecting them will not be enough evidence.
There are people who say, well, if we find oxygen is a biomarker, water is a biomarker, and that's not true. Any compound can appear on the surface of a planet in a completely natural way, either from geological processes or chemical processes. We only have one biomarker, the one we have now on Earth, which is the simultaneous presence of large measurable quantities of water vapor, oxygen or ozone, and methane, and you could substitute CO2 for methane. If you have those 3 gases coexisting in that atmosphere, there is nothing that can sustain it except the presence of the life cycle. So that is what we are going to look for. But even for the Earth, which is 4.8 billion years old, this only applies to the last 1.5 billion years or so. There was a very long period when there was life on the surface of the Earth, a bacterial life that had not yet altered its atmosphere and had not yet put oxygen in it, and thus we would not be able to detect it. We couldn't be sure that such a world is habitable.
Add to that many other details. Does the exoplanet have a magnetic field protecting it from dangerous space radiation? Is the planet geologically stable? For now, we can't answer these questions, and they will certainly be stringent criteria for considering an exoplanet suitable for life. But I don't want you to leave with a bad taste in your mouth. The truth is, statistics are in our favor. If out of the 4,000 planets we have found, there are already 20 that look promising, extrapolating this to the hundreds of billions of star systems in our galaxy gives us billions of potential Earths. Obviously, this is an extremely crude prediction and should not be taken too seriously, but it gives us hope. Hope of finding not only new homes, but also new friends. Going even further, if all these amazing techniques have helped us to find out all this stuff about exoplanets, couldn't we use them to discover other celestial bodies orbiting other stars? Things like moons, comets, or maybe something more exotic? We will talk about that in our next video. And remember, if you want more science, just hit the subscribe button. Thanks for watching.